This lesson deals with by substitution, which is really a fancy way of saying we're going to undo the chain rule, right? Because all the antiderivatives that we have done so far have been, well, all of them except for a little bit of trig, have been polynomial. So the only technique that we know so far is really just bumping up and dividing for each one. So undoing the chain rule is not really that complicated, but it does require some technique for this, right? So what I have right here is a very basic function. It's in general terms. So what I'm saying is here, take the derivative of f of g of x. Well, you can see that that's a composite function, one inside of the other one. So the process that you go through to take the derivative of this, you say, okay, the derivative of the outside, so that's f prime, you copy the inside, and then you take the derivative of the inside. Agree? That's what we go through all the time. All right, so if this is the original function and this is the derivative, and I say take the antiderivative of this, so look, I put this right there because I want the antiderivative of this whole thing right here, then if I take the antiderivative of this, I better get back my original function, which is what I have right here, except that I have a c on there because I'm talking about antiderivatives and I have to put a chucklehead on there. All right, so we're going to go and look for some patterns on here on how this is done. All right. Let's concentrate on this problem up here. Okay? We're going to fill in the table in a minute, but we're going to concentrate on this one first so that you can see how this is done. So I'm going to say, let's take the antiderivative of 3x to the 7th plus 11 to the 5th power times 21x to the 6th dx. And I did attach the dx on there because I am taking the antiderivative using this integrand symbol. Now remember, the title of this topic is called U sub. The U is because the notations that we use for this technique is the letter is U, and the sub stands for substitution. So here's the process that we're going to go through. We're going to rewrite this integral in a different way in terms of U's only. So if I'm using U's, I'm also going to use du's. So this whole problem is going to become, it's going to look very different, but it's going to look very simple. So that way you can maybe just bump up and divide, use other techniques that you already have in your pocket. Okay? So I'm going to say let U I'm going to choose something from this integrand right here to call my U. I have the option. I have the option of calling this whole thing right here my U. I can call the inside of this my U. I can call everything here, including the exponent of a phi, my U. So you have a lot of flexibility. However, there's only one way of solving this with the U sub technique. If you choose the wrong U, you're not going to be able to solve it. So what's difficult about this technique is figuring out what's going to be your U. And you're like, okay, Flores, tell me, how is this going to be done? Here's what you have to do. You have to choose a U that when you take the derivative of that U, the derivative is also in here. Did y'all understand what I said? Fast? You have to choose a U that when you take the derivative of this U, the derivative is also here. Right? You're like, yes, I get it. Show me. All right? So I'm going to let my U be this right here. 3x to the 7 plus 11. I did not choose the exponent. Now I'm going to take the derivative of this U. So concentrate on this piece right here now. Take the derivative of U with respect to x. What's the derivative of U?
21x to the 6.
The derivative of the U.
21x to the 6.
I'm not talking about the other side. The derivative of this U with respect to x. du over dx. The derivative of this with respect, because if I take the derivative with respect to x on the left side, I have to take the derivative with respect to x on the right side. So the derivative with respect to x on the right side is just going to be 21x to the 6. The derivative of 11 is just 0, and the derivative of this whole thing with respect to x will be a dx over a dx, but that's just really a 1, so we leave it alone. So far so good? Now what I'm going to do is I'm going to multiply both sides by dx because I want x's and dx's in one side, u's and du's on the left side. So this is not going to help me with this technique. So I'm going to multiply both sides by dx. That cancels. So this process, we've done it before. So du equals 21x to the 6 dx. So 21x to the 6 dx, it's here. So I can replace this 21x to the 6 dx with a du. So this whole integral now becomes, what did I call the inside part? U. U to the 5th. And this part now is du. Now, isn't this much simpler to solve than solving this messy stuff right here? Sure is. How do we integrate this? What technique? Bump up and divide. So let's bump that one up. So that will give me u to the 6 divide 1/6 plus c. And you're like, got it, Flores, I'm done. Not quite. These u's, you made them up. It has nothing to do with the problem. They gave you this problem in terms of x's. You have to give the answers back in terms of x's to them. So let's rewrite this as 1/6. This u is going to be replaced with your u. Final answer.
That's their luck.
It's still good.
That's when you bring your samosa. Yeah. Y'all tried it, right, last time?
Yeah.
You just, they brought the small ones. I thought they were going to bring like the big ones. I guess those are good because you can dip them in the sauce, but no sauce, it's like, I don't know.
Go across the street. Some of your finest sauce.
Get some Valentina and just, woo! Is that what it's called, Valentina, right? I don't know. It's kind of like eating fries without ketchup. It's like, who does that, right? Or eating ketchup without fries. All right, so this is where we stop. So what I was saying here is that when you get to this stage is one of the few things that you can actually go back and check whether you actually got the right answer or not. Because all you have to do is take the derivative of this by doing the chain rule, and if you get back whatever is inside of the of the integral, or in other words the integrand, and if it's identical, then you got the right answer on this. This skill more than likely will be tested on the free response. So it will be part A, B, or C, somewhere there, and it's typically worth 3 points. They give you a point for using the right process for the U sub. And so in other words, choosing the right thing up there. They give you a point for finding the du. They give you a point for taking the antiderivative correctly. And they give you a point for replacing that back where it belongs to. You might have to find the C also. And they can tweak the problem. It can be a PBA problem. It can be anything, right? But the U sub technique will be tested. We already done this one. I decided to call this my u, 3x to the 7 plus 11, because when I take the derivative of that, it's already there in the integral. Each of these is going to be one integral. So my u is 3x to the 7 plus 11, and my du is just 21x to the 6. What would you call your u in this problem? The 20x to the 4th or the square?
4x to the 5th minus
Would you include the square root?
No,
No.
Why not?
that won't give you the second.
What's wrong with including the square root?
With
That won't
the,
give you.
it'll be positive and negative.
Yeah, you'll have something to the 1/2, right? And then when you take the derivative of that, you'll have 1/2 copy the inside times the derivative of the inside. It's going to be really, really messy. And the only thing that we need to get out of that u, when you take the derivative of that u, the du is only that. That's all we need. So obviously it has to be the inside portion. So the inside will be 4x to the 5th minus 5x, because the derivative is 20x to the 4th minus 5, and this is already there. How about this trig problem right here? Tangent? Why?
Because the derivative
The derivative of tangent is
secant.
secant squared, right? Could you have called your u secant? What's the derivative of secant?
Oh,
Secant
yeah.
tangent, right?
Oh,
Yeah.
But right here, if you erase that 2, you have another secant right here, right? So the derivative of secant is secant tangent, but you need another tangent. You have that extra tangent on there. And how are you going to replace that tangent? You see that? That creates a problem. So it's better to call your u just tangent, because then you can just replace this one with its derivative of u, right? Obviously, yeah, right here you will have a u squared. We'll work this problem so that you can see exactly what we're talking about. So your u is just tangent x, and your du is secant squared x. And what about that one? What would you call your u? Maybe I should have put this problem right here in the bottom, right? What options do you have there? I mean, can you call your u2? Then du is 0? That would not work.
2x.
2x? Or maybe sine 2x?
I was thinking that it would be for sure.
Let's try sine 2x, all right? Sine 2x is my u. What's the derivative of this u? Cosine 2x times 2. But I don't even have a cosine here. So that's not really helpful. So I went through 2 options already. So the only one that I really have left is calling my u 2x, and the derivative is 2. And that 2 is already there.
So what is the sign?
We'll work that problem. All right, so I want you guys to give me this one and the last 2. So we're gonna, all right, so here we go. Let u equals 2x, du equals 2. Remember, right here we're gonna have a dx right here, but since you're multiplying both sides, this would always be true. So we're not going to be playing this game of multiplying both sides by dx. From now on, we're just going to take the derivative of u. We're just going to put du right here. And on this side, we're just going to take the derivative and slap on the dx next to it. All right? So that we can avoid doing all this. We have a 2x dx. There's the 2, and there's the dx. So this sign is going to be replaced with another sign. So that's not a problem. So it would be sine. The inside, we decided to call it a u. Please put parentheses on there. Don't call it sinu or sinu, right? It is really funny. Yeah, since we did talk about that in my previous class, pre-calculated. And 2dx is this right here, which is really du. So now we can take the antiderivative of this. We're not going to use bump up and divide because this is not a polynomial. The derivative of what is sine? Cosine. Ooh, not x. Coscu? No. The derivative of cosine is negative sine, but this is positive, so we have to put on a negative in front of it. Plus c. Replace the u, so negative cosine of 2x plus c will be my final answer. Did that help? Fernando, since you're the one that had this question, you're kind of like, how's that going to work?
Yeah.
It wasn't too bad, right? Baby problem. All right, let u equals, from the table we decided to call the u 4x to the 5th minus 5x. Du equals 20x to the 4th minus 5. And this is where I skipped that step of multiplying both sides by dx. I just put that in parentheses and slap on a dx on there. That dx will actually come from right here from the bottom. And I'm ready to start replacing this because this is an identical match to that. Integral, square root of u, du. Don't you love it when something that complex just becomes really simple? And this is really the square root, the square root of u is really u to the 1/2 du. And we can bump that up. U to the, we have 2 with a plus in there. It's 3/2. We have to divide by this, is the same thing as flipping it. Plus c. So it's 2/3 u. Three halves plus c. Booyah. I lost you, Fernando?
What happened to the du after?
The du disappears because you're taking the antiderivative.
It's a minus 5x, isn't it? 4x minus 5?
Oh, am I missing something here?
Yeah.
The x there? Okay, gotcha. Thank you.
Oh yeah, so you're taking the antiderivative, so the du.
Future lessons, I will explain what the dx represents. Okay. Right now, I kind of just giving it to you that when you're taking the antiderivative, that dx disappears, but it does have some meaning. If you're using this symbol, you better have a d something in there. Now, if they give you some problem like y prime equals 3x, and they say take the antiderivative, then you don't need a dx on there because they're telling you to take the antiderivative. But if they don't tell you anything, they just give you this, that means nothing really. It doesn't even mean to take the antiderivative unless you complete everything with the dx on there. Okay? We had the same question that Ivan asked, and he was just not really happy with my explanation. I said, well, you can't learn everything in one day, right? You gotta take your time. Right now, I'm concerned about you learning this use of technique, and then we go deeper into where that came from? I mean, how many of you know where that came from? What does it really mean, right? But you learn that it's actually this. The sigma. But we'll get into that, right? Why did it become elongated? I don't know. Well, I do know, but we'll get there, right? So you're like, some of what? What are you really summing? Right? So yeah, those are really great questions, but one step at a time. You're like, chill, you can do this. It's not that bad, all right? Problems when they give me a ratio like this, I try to make the problem look different. Not all the kids do this, and I don't, but I teach it this way so that way, just in case you're in that little group of kids that do not see it right away. So you can see that there's going to be something that I have to get from the problem by using the U strategy. So let U equals 5x squared plus 7. So du equals 10x dx. There it is, right? And sometimes it's not easy to see it. Well, it's there, but it's not as clean as writing it this way, right? So now we're going to have to write the integral of 1 over u cubed du. That being my du right there. We can bring this up, so there's the integral of u to the negative 3 du. We can bump it up, so that becomes u to the negative 2 divide, so it's negative 1/2 plus c. So it's negative 1/2, replace the u plus c. And we can always clean this up. First response, you can kill it there and full credit. Leave it on the top, bring that to the bottom. I'm missing a 2. All right, let u. Again, it does take practice. So for trig, you will have to ask yourself the derivative of whatever I choose. Is it there? The derivative of tangent is secant squared, so that would be a good choice. But you know what? The derivative of secant is secant tangent.
Yeah.
That's actually the same thing. Huh? That is probably. But there's 2 secants right here, right? So if I choose one of my u's to be one of those secants, then I'll have a secant and 2 tangents left. So it's not a good choice. No, okay. So we go with tangent. So du equals secant squared x dx. So this becomes the integral of one tangent is 1u, so this is just u squared, and secant squared dx, it's a perfect match, so that will become just the u. So this becomes uq after you bump it up and divide, plus c. So it's 1/3 tangent qx plus c. I lost you, Pedro? Yeah. Where?
If you have to rewind back to.
Because this is how many tangents?
Yeah, then what happens to the other secant square?
Well, what this piece right here, secant squared dx, is this right here, right? And that's exactly only what? It's only du. So I'm replacing this whole thing with a du. You see what I'm saying? So that's why we keep saying, you choose a u that when you take the derivative, it's there, completely there. And the problems are designed so that you can, they come out nice. There's really not much that that you can do here to make mistakes. mean, the worst case scenario is that you choose the wrong U, and then you'll be stuck right there. You know, so you just backtrack and try a different U until it works.
Would it have work with secant?
Excuse me?
Would this have work with secant?
No.
What if what?
Would it have work with secant?
Secant is
If you secant as your U, well, you would have. Let's try that. Let's try that. If the U was secant x, so this is secant x tangent x dx. So you would have, you need to replace one secant. So that becomes one of those. They're still there, but one of those would become one U. And I still have one secant, and I still have a tangent square. So from here, I can replace the secant in one of the tangents. But I would still have, let me write all this.
You would have tangent.
Tangent x, secant x dx, right? So let's start replacing. That one can be a U. A secant x dx and a tangent, that's a perfect match for that, and that would be a du. But you still need to replace that one. And you have no way to replace that one. So it's a no-go on that one. Let's try that. What did you choose as your U?
The inside.
The inside, because he's going to spit out some x cubed out of it.
Yeah, but it
All right, so let U x to the 4 plus 3. du equals 4
4x.
cubed dx. All right, let's see if we can start replacing. This is going to be a U, so that's a U squared. Got it. I need to replace the x cubed and the dx, and that's only here. So I have no need for that 4, right? So let's get, excuse me?
Why don't you have a need for the four?
Because I only need to replace these two things right here.
Okay.
I don't need a 4. Unless I had a 4 right here, then it would be a perfect match, right? But I don't. So I need to remove this 4 from here. So I'm going to divide both sides by 4. So I have 1/4 du equals x cubed dx. And now it's a perfect match. But now you need to replace what you need with whatever you have on here. So you need to throw in a 1/4 du. You can bump this up and divide, but we're gonna just try, to learn the rules that we have learned before. So we're gonna move this 1/4 outside. And that is 1/4. Bump up and divide this u squared. It becomes u cubed. And divide is 1/3 plus c. So that becomes 1/12 u cubed. 1/4 times c is just another constant, right? So we can just call it, big C, D, or something else, right? I don't know. It's really up to you. Let's call it big C. And then let's replace the u. So it's 1/12 x to the 4th plus 3 cubed plus big C.
You are so sneaky because you know what homework and you want to sit here and rattle our little brain at 9.
If there's no challenge, then what's the whole point?
For me,
I believe that they're going to start looking at the jackets to see what y'all
how you
decide.
gonna skip from shirts to jackets? When you got shirts?
The shirts is for the prep session, so that does that 4 bother you? Does that 4, it's not quite there. You get a 2, it's not 4.
So you need your pipeline, sure you right?
No. So for my U, I used the inside because just give you x cubed. So you have x to the fourth plus 5. And so du is 4x cubed dx. But you have a 2x cubed. So to get 2x cubed, you divide this by 2. So you'll have 1 half du is 2x cubed dx. Which is this. So this becomes your u, and this is just 1 half. So this can go away because that's your du. And then you have times a half. Now you bump up and divide. So let me write it differently. So to bump up, you're going to do 2 over 2, so that'll give you 3 over 2 u. And then you have 1 half, and you're dividing it by 3 over 2, so that'll just make it times 2 over 3. Then that'll give you 2 over 6 u. Excuse me. 3 over 2.
Plus C.
Plus C. Don't be a chucklehead. So now you just put your u in. X to the fourth plus 5 over 2 plus 6. So 2 over 6 can be reduced.
I can't see.
Y'all look at me.
Good job.
I know. That's why I want to follow my path.
Very good. What do you think?
I agree.
Good job, right?
I'm failing
So I'm going to use
The x squared plus 3. The x
calculus.
squared is greater than x.
You don't know what she's saying.
And then du is 2x, but I need x myself. So divide 2. And then I have 1 half du equals x dx. So then this is my u. And then I attach the 1 half du to it. And then bring out the 1 half out. And then bump up and divide.
That one disappears. 1 half bracket.
And then I'm gonna the 1 half and the 1 over 10. I'm gonna multiply. So I'm gonna have 1 over 20. And then I'm gonna plug in the u, so x squared plus 3.
Call it a different letter. Hey, I have something to say from Ronaldo.
Stupid.
I'm stupid. Right now I'm looking smart.
Well, thank you. All right, so we go through the process. Can we bump up the divide in here? Not really, because it's not a polynomial. Can we simplify this? Maybe. Or maybe we can go straight into U sub. Any comments or ideas on this one?
Yeah.
Go straight to U sub?
Yeah.
Uh,
Cause you get 3x squared.
Yeah, that's pretty straightforward, right? So let U equals 3x, x cubed plus 1. Do notice that I put that in parentheses there. So du equals 3x squared dx. Sometimes you will see me doing something like this. There it is. And there's a 1 at the top, this whole thing. So that's 1 over u to the 4th. And that is nothing more than a du. Move this to the numerator. A lot of the kids have the tendency of taking the antiderivative of this or bumping up and dividing and still keeping the integral sign on there. Once you bump up and divide, that goes away. You have done the antiderivative already. So let's go ahead and bump this up. So it's u to the -3 divide plus c. And that becomes 1/3 u, which is x cubed plus 1 to the -3 plus c. And yes, you can bring that to the denominator if you want. If you're doing a free response, you can kill it here. You will get good credit. But if you're doing a multiple choice, then you would have to make it match one of the choices given to you. In general terms, they love to test concepts with g's of x's, f of x's, p primes, f primes, big F's, all of those. But as you can see, they look difficult, complicated, but they're really not. You will still, the technique will still be tested. What would you choose as your u here?
X.
X to the 5th. So du equals 5x to the 4 dx.
Yeah.
So there's 5x to the 4th, and there's the dx. So those two combined is a 1 du. Do not put the du in the front. Make it into a habit and put it all on the back. And the g prime stays there, and that's just a u. Antiderivative of little g prime is
G.
little g of u plus c. So this is u of x to the 5th plus c. Easy, yeah, man. You'll find some of those. You'll find some of those on the multiple choice questions.
That's it.
So that would wrap up use substitution. I do have other ones for homework that they have a different type of twist, but those don't really come up on the AP exams. I've seen maybe 2 or 3 at the most of all the exams I've seen. But I do have a few there so that you can be exposed to the strategy for those.